Hi everyone, this is Mrs. Trigno and I am back with page 4 of the second review packet for the first semester Algebra 1B exam. Page 4 starts with some absolute value equations, and these were the ones that we probably did the most recently out of all of the material on this packet. We just talked about these last week. Notice that only the m is in the brackets here. So that means I need to clear everything away from those brackets before I even do anything with the m. So I will start by subtracting 3 from each side. That leaves me with 2 times the absolute value of m is equal to 2. And then from here, I don't want to multiply here. I don't want to take the 2 and multiply it by the m, because the m is inside the brackets, and I can't mix numbers that are outside the brackets with numbers that are inside. So instead I want to think about how I could get rid of that 2. And I'm going to do that with division. I'm going to squeeze that in there and then carry on up here. So here that 2 will cancel out, and then I'm left with the absolute value of m is equal to 1, because 2 divided by 2 is equal to 1. Now, we're not done here. Okay, the absolute value of m equals 1 means that m is one space away from 0 on a number line. So I want you to think about a number line and think about which numbers are one space away from 0. Well, obviously 1 is one of them, but then we could also have -1. Okay, so we must have both answers there, because there are 2 numbers that are one space away from 0. Anytime you're solving an absolute value equation, you're going to end up with 2 answers. Okay, so don't forget about that. You could also write this, just so you know, and we've talked about this back when we talked about square roots. You could write that as m equals plus or minus 1. Okay. On to number 19. Number 19 is very similar. It's in the reverse order from what problem number 18 was, but it still works the same way. If it bothers you that it's written in that order, you can always rearrange it. You could move the equals 14 over to the other side. But I still want to start by clearing everything away from the brackets here. So I'm going to start by subtracting 2 from each side. And that'll leave me with 12. Equals 3 times the absolute value of x. And then to get rid of that 3, I'll just divide and carry on up here. 12 divided by 3 is 4, and my 3's will cancel out, so I'm left with 4 equals the absolute value of x. Once again, that's saying that x is 4 spaces away from 0. So we need to think about what numbers could be 4 spaces away from 0 on a number line. Well, it could be 4. But if I went the other direction, it also could be -4. So x equals 4 or -4. You have to have both answers to be correct. And watch out for that one, because remember, the majority of your exam is a multiple choice. And a question like this, if it were multiple choice, would probably have just 4 as one of the possibilities, or it would have 4 or -4. So you have to make sure that you don't just grab the first one that jumps out at you, that you really think about it. Okay? And again, we could write this as plus or minus 4 as well. Okay? Really, absolute value works very similarly to just solving equations. You just have to remember that you have 2 answers at the end of it. Okay, let's take a look at problem 20. Problem 20 is asking us to expand and simplify. Remember, expand just means to use this square here, and that square means that we need to take this this quantity or this stuff in the parentheses and write it out twice. So this would become -3x minus 2 times -3x minus 2. So that's what it means to expand, to write it out twice. Now to simplify, we need to multiply them together, which means we're going to use FOIL. Remember, FOIL stands for first, outside, inside, last. So first, the first terms in each set of parentheses would be the -3x and the -3x. -3x times -3x, be very careful there. First of all, -3 times -3 is +9, and x times x is x squared, so that's going to give us 9x squared. Remember that anytime you multiply an x and an x together, you end up with x squared. Okay, the next letter in FOIL is O. That stands for outside, so we need the outside terms in the parentheses, the ones on the edges. That would be negative 3x times negative 2. Negative 3 times negative 2 is positive 6, so this would become positive 6x. The inside would be the 2 on the inside, so negative 2 times negative 3x again is positive 6x. And then L stands for last, which would be negative 2 times negative 2, which is positive 4. Notice that these two middle terms are exactly the same, and we did talk about this in class, that anytime you're squaring a parenthesis, you will end up with the middle terms exactly the same. And those you can combine because they are like terms. However, remember, you cannot combine those with the x squared over here, okay, because x and x squared are not the same thing. So here, this would just be 9x squared plus 12x plus 4. And that's it. That's as simplified as it gets. Okay, we can just leave our answer just like that. Okay, problem 21 works much the same way. Again, it's asking us to expand, so I'm going to write out 2x plus 1 times 2x plus 1 and simplify. So again, I'll use FOIL. First would be 2x times 2x, which is 4x squared. Again, don't forget that x times x will give you an x squared. 2x times 1 gives you 2x. 1 times 2x gives you 2x. And 1 times 1 leaves you with just 1. Okay? Once I've got that written out, I can combine my two middle terms because they're both x's, and that would leave me with 4x squared plus 4x, because 2x plus 2x is 4x, and then plus 1. And that would be your final answer for number 21. Okay. 22 involves Newton's formula, which again, that formula will be given to you on the exam. You just have to know how to plug numbers into it. Here's what that formula looks like. Negative 1/2 gt squared plus v sub 0 t plus h sub 0. And the only numbers you really need to worry about filling in are the g, the v, and the h. Okay, those three are the ones that you're putting numbers in for. This t is just going to remain a t. Okay, so let's start writing this. H equals negative 1/2. Now g, that was that constant number that we talked about that represents the force of gravity. And so that number will always be either 32 or 9.8, depending on whether you're in feet or meters. And again, that information will be on the formula sheet for you as well. This problem is in meters. So that means we're going to use 9.8 for g, and then I'll leave my t squared in there. The v sub 0, that stands for your initial velocity, and it gives us right in the problem that the initial velocity is 23 meters per second. So that'll be 23t. Again, keeping that t from the original formula. And then h sub 0 is your initial height. It's the height that your object is starting at. Well, it looks like our object is starting from a platform 8 meters off the ground, so I'm going to say plus 8. For the most part, we're done here. The only other thing we should do, oh, I'm sorry, you couldn't see that. The only other thing we should do is combine the negative 1/2 and the 9.8. And that will make our final equation negative 4.9 t squared plus 23t plus 8. Okay? So writing those equations is really just a matter of plugging the right numbers in at the right spots. Okay? 23 is very, very similar. Again, we're going to use Newton's formula. So I would write, just to start with the formula again, negative 1/2 gt squared plus v sub 0 t plus h sub 0. Okay? And again, we are just going to fill in G and V and H. Okay? Now this problem is in feet. So this time we're going to use 32 as our gravitational constant. So I would say H equals -1/2 times 32 t squared plus, now this time the problem doesn't give you initial velocity. Well, it does, but you have to sort of interpret here because it says here that this ball is being dropped. Now if it's being dropped, that means there's not any force put behind it. So in this case, anytime your object is just being dropped without being thrown, your initial velocity is really 0. Okay, because that's supposed to represent how much force you're putting behind the object. And then we are 19 feet off the ground, so our h sub 0 would be 19. To simplify this one, I am going to combine these two just like I did before, and I'm also going to cancel out this middle term, because if you have 0t, you really don't even have to include it in your equation. So I would say h equals -16, because that's -1/2 times 32, t squared. That 0t cancels out, and then I'll have plus 19 at the end. And that would be your final equation. Okay, 24 and 25 deal with solving inequalities. And when you're solving inequalities, it's very, very similar to solving equations. There is only one exception to that, and you'll actually see that exception when we do problem number 25. But here, just as if you were solving an equation, if I were trying to get c by itself, I would add 3 to each side. So I would end up with 2c is less than or equal to 8. Let me just rewrite that over here. So 2c is less than or equal to 8. Okay. And then I would divide both sides by 2 and end with c is less than or equal to 4. That's it. That's your final answer for that one. Okay. 25, we're going to do exactly the same way. Subtract 6 from each side. So I end up with -3g is greater than 3. I guess I'll move over here. Hopefully you can follow that, okay? Here, we'll draw a line under here. Okay, so I end up with -3g is greater than 3. Now this time, I'm going to divide by -3, and this is that one exception that I was talking about. This is the only thing that's different from regular equation solving, is that when you're solving with inequalities, anytime you divide by a negative number, and it's only if the number is negative that it matters, anytime you are dividing by a negative number, like I did right here, I have to flip my inequality sign around. So this would really become g is less than -1. Okay, and again, I got -1 because I did 3 divided by -3. Okay, so just watch out for that when you're solving inequalities. Make sure that if you divide by a negative number, you flip that inequality symbol. Okay, 26, 27, and actually 28 on the next side all sort of go together. And it's going back to when we were talking about systems of linear equations. Okay, a system of linear equations is 2 linear equations at the same time. And normally when we graph 2 linear equations at the same time, it'll give you 2 lines that cross someplace. And that point where they cross is their solution. Now we did some other things earlier where we did substitution and elimination. That's sort of a mathematical way of finding that intersection point. But what it really comes down to is you're looking for the place where the 2 lines cross. Now in this case, number 26, it wants a system of linear equations that has no solution. Well, we just said the solution is the place where they cross. So no solution would mean that they never cross, that there's no point where they cross. Think about what types of lines never cross. And hopefully you come out with, I guess I should put it on a graph. So here's just a little baby graph. And the lines would be any lines that are parallel to one another. Okay, so the big thing to take away is that you want 2 lines that are parallel here if you have no solution. Okay. 27 just wants you to have one solution. That means they cross at one point. So again, let me draw a quick graph. Okay, and you just want two lines that cross somewhere, anywhere. So here's one line, here's another line. Okay, it doesn't matter where they cross, but we would call this point right here their solution. Okay, it's the place where they intersect. I'm going to go ahead and flip over to the next page and do 28 because 28 goes along with these problems as well. Problem 28 wants a system of linear equations with infinitely many solutions. That means they're going to cross everywhere. And here's how that happens. Here's our little graph. And this will happen if you have one line and then the other line laying right on top of it. And I usually just make it sort of a darker or a bolder line to show that it's two lines really on top of one another. Okay? Because two lines laying right on top of one another cross everywhere. They intersect everywhere. So that's how they come to have infinitely many solutions. Okay, that does it for this section of your review. Next up will be page 5.